The top paleoanthropologist in the world just said that the out-of-Africa model of human evolution is wrong. For more than a century, paleoanthropologists have struggled to understand humanity's Middle Pleistocene past, a long, murky chapter between the emergence of early Homo erectus and the rise of recognizably modern humans. This period, stretching from roughly 800,000 to 300,000 years ago, contains some of the most important events in the evolution of our genus. Yet it has remained notoriously difficult to decipher because the fossil record is fragmentary, geographically uneven, and complicated by deep population histories that resist simple classification. This confusion has often been referred to almost jokingly as the muddle in the middle. The phrase captures just how confounding the period has been. Fossils across Africa, Europe, and Asia show mixtures of primitive and derived traits. Lineages overlap or blend. The sharp evolutionary boundaries that paleoanthropologists long hoped to draw from Homo erectus to heidelbergensis to Neanderthal to Homo sapiens blur upon inspection. The Yunxian fossils from central China, long known yet long misunderstood, are now helping illuminate this shadowed era. In a recent commentary posted by Chris Stringer, who has been called the Don of human evolution studies, he argues that Yunxian 2, dated to roughly 1 million years ago, sits remarkably close to the ancestry of two major branches of the human family tree: the lineage that would give rise to Homo longi and the Denisovans, and the lineage that would lead eventually to modern Homo sapiens.
It's worth saying that one of the big names behind that particular piece of research is Professor Chris Stringer, who is also, you might have noticed, our chief consultant on human and also an absolute don, if not the don, of the field. So really, really interesting. Still too early, still too controversial, but really interesting implications if a number of other things are proven correct.
Where did the ancestral populations of Neanderthalensis, sapiens, and Denisovans live, according to Stringer? The evidence from Yunxian and Homo antecessor suggests that their Eurasian distribution suggests an extra-African origin for these lineages. This is mind-blowing to hear from Stringer, who practically invented the out-of-Africa theory in the 1980s. The term extra-African origin is especially provocative. It does not negate an African homeland for Homo sapiens. Indeed, Stringer emphasizes that the species likely continued evolving in Africa later, but it opens the possibility that earlier evolutionary events occurred in Eurasia. This would put East Asia at the heart of early human diversification rather than on its periphery. These are just a few of the bombshells in the commentary by Stringer. Indeed, his statement carries enormous consequences, implying that some of the deepest roots of our species lies not only in Africa, as is traditionally thought, but also in Asia. And it would mean that the Denisovan line, once hypothesized to be a recent offshoot, is at least 1 million years old. To understand how far-reaching these implications are, we must follow the path that brought researchers here, a story beginning on the banks of the Han River. The monumental finds from Yunxian lie along the left bank of the Han River, a tributary of the Yangtze in Hubei province. 3 crania have been recovered: Yunxian 1, discovered in 1989, Yunxian 2, recovered in 1990, and Yunxian 3, unearthed in 2022. The first 2 specimens are partially distorted. Yunxian 1 in particular is badly crushed, while Yunxian 3 remains under preparation with the results to be released in 2026. Dating methods, including paleomagnetic reversal stratigraphy and biochronology, place the Yunxian deposits between 940,000 and 1,100,000 years old. That alone makes them extraordinarily significant. Very few hominin skulls of such antiquity approach this degree of completeness. For decades, the identity of Yunxian 1 and 2 lay unsettled. They were variously attributed to Homo erectus, Homo heidelbergensis, or even vaguely described as archaic Homo sapiens. But only recently have new tools allowed researchers to peer through deformation and reconstruct their original 3-dimensional shape. With high-resolution structured light scanning and CT analysis, Stringer and collaborators digitally restored the cranium of Yunxian 2, even incorporating a few anatomical elements from Yunxian 1 to produce the most accurate representation yet. What emerged surprised even veteran researchers. The cranium is long and low, a hallmark of early Homo, but its endocranial capacity, approximately 1,143 cubic centimeters, is unexpectedly large for such an early date. Its face and occipital region show a blend of traits that do not map neatly onto existing categories. Some features resemble East Asian fossils like Harbin or Dragon Man, assigned to Homo longi, others align with Homo sapiens. Stringer summarizes this bluntly. The results reveal a fascinating mosaic of primitive and derived traits. This mosaic is key. Over the past 10 years, discoveries from East Asia, including Harbin, Yunxian and other fragmentary remains, have hinted at an untold complexity in the region. Yunxian too appears centrally placed among them, linking these fossils through shared features and hinting at a deep ancestral root. The research team employed both geometric morphometric analysis and parsimony-based phylogenetic tools to determine where Yunxian 2 fits. In both approaches, the result was the same. Yunxian 2 represents an early member of the Homo longi clade, a grouping that probably also encompasses the Denisovans and several other Chinese fossils near the age of Harbin. Even more striking is the relationship with Homo antecessor from Atapuerca in Spain. The analysis showed that Homo antecessor clusters closely with Yunxian and the Homo longi clade. Together, Yunxian 2 and Homo antecessor appear as a sister group to the sapiens clade. If this is true, the implications are profound. The Denisovan lineage, Homo antecessor, and the direct ancestors of Homo sapiens share a common stem that may predate 1 million years ago in Eurasia. This conclusion is deeply at odds with traditional views of modern human origins, which place the root of Homo sapiens firmly in Africa. It suggests that the story is far more entangled. The new analysis helps clarify one of the most persistent challenges in paleoanthropology: how to grapple with the dizzying diversity of Middle Pleistocene hominins. According to the new results, most large-brained hominins of the last 800,000 years can be assigned to one of 5 main groups: Asian erectus, heidelbergensis, Neanderthalensis, sapiens, and the Denisovan lineage. This framework is far more structured than previous models. It acknowledges that several lineages coexisted, diverged, and interbred long before the rise of classical Neanderthals or modern humans. Equally significant is the treatment of Middle Pleistocene African specimens such as Kabwe from Zambia and Petrolona from Greece. The researchers conclude that classic Homo heidelbergensis represented a distinct and more ancient branch, diverging as early as 1.5 million years ago. This suggests that Heidelberg people were not direct ancestors of Neanderthals, Denisovans, or modern humans. Instead, they were a side branch, one of many. As Stringer notes, the early diversification of these lineages was relatively rapid, implying that undiscovered or unrecognized early representatives of these clades must exist in the fossil record. In other words, our family tree is not a simple ladder, but a bush, with many stems sprouting early and evolving in parallel. Because Yunxian is roughly 1 million years old, its placement helps anchor the timeline for other branches. If it is indeed an early member of the Denisovan clade, then the minimum age of that clade must be at least 1 million years, forcing similarly deep ages for the roots of Heidelbergensis, Neanderthals, and Homo sapiens. Yunxian thus sits near a pivotal divergence where Asian and African branches separated. This raises a tantalizing question. What makes these findings transformative is that they help resolve the muddle in the middle that has preoccupied researchers for decades. Stringer writes, "We feel that this study is a landmark step towards resolving the muddle in the middle through the recognition of 5 main groups of later large-brained humans." For Stringer personally, this shift represents a major re-evaluation. When he began working in human evolution 50 years ago, the East Asian record was either marginalized or its fossils were only ever considered as direct ancestors of recent East Asians. That assumption, common for decades, is being upended. East Asia now appears to preserve crucial evidence for the global history of human evolution. The picture that emerges is one of multiple deeply rooted lineages diverging rapidly around 1 million years ago and developing alongside each other across Eurasia and Africa. Interbreeding blurred boundaries and populations rose and vanished with climatic shifts. Yunxian may be the clearest window yet into that pivotal moment. One of the most striking developments in recent years is the degree to which interbreeding shaped our lineage. Genetic evidence has already revealed extensive admixture between Neanderthals, Denisovans, and modern humans. Now, even earlier lineages appear to have intermingled. Stringer and colleagues note that hybridization between lineages, gene flow that could have blurred morphological boundaries, undoubtedly occurred within species and also between some of the species. This also may explain the unusual Xuchang or Lingjing chronia from China, whose mix of features has long puzzled researchers. Admixture also means that evolutionary branching was not clean. Species boundaries were porous. The Yunxian evidence challenges the once dominant idea of a simple single-origin model for Homo sapiens, according to Stringer. New genomic work suggests deep population structure and regional differentiation within Africa that later coalesced. This means that different African populations contributed to the formation of modern humans, but it also leaves room for earlier phases of diversification outside Africa. Even if the ultimate emergence of Homo sapiens occurred in Africa, its ancestors have roots that stretch back to Eurasian populations like Yunxian. This, in turn, raises the possibility of into-Africa movements during the Middle Pleistocene, followed later by the outward expansions 60,000 years ago, according to Stringer. The story is not linear, it is braided. Recent genetic studies deepen the complexity. Research from Ranis in Germany and Zlati Kun in Czechia shows that Homo sapiens arrived in northwestern Europe roughly 45,000 years ago, but in small groups that left no lasting genetic legacy. These early pioneers appear to have vanished, replaced by later arrivals who had also interbred with Neanderthals. The same studies reveal that the Neanderthal interbreeding event occurred around 48,000 years ago, younger than many earlier estimates. The shared timing of this event constrains the arrival of modern humans into regions such as East Asia and Australasia to after 48,000 years ago. Similarly, interbreeding with Denisovans must be younger still. These findings imply that fossils or archaeology older than 50,000 years outside Africa probably represent populations that subsequently died out without giving rise to any contemporary populations. Multiple dispersals of early Homo sapiens were absorbed, later expansions survived and thrived. One of the most intriguing findings is that Neanderthal ancestry declined sharply over time. Strong selection acted against newly acquired Neanderthal DNA over the next 100 generations, except where advantageous traits persisted, including genes linked to pigmentation, immune function, metabolism, and even some conditions such as autism. This selective pruning suggests that while interbreeding was widespread, only parts of the Neanderthal legacy proved beneficial. The Yunxian fossils have emerged as a pivotal touchstone in human evolutionary studies. They reveal a species complex in motion, diverse yet interconnected, branching yet entwined. If Yunxian too truly sits close to the origins of both the Denisovan and sapiens clades, then its significance is hard to overstate. As Stringer writes, the site may represent one of the most important windows yet into the evolutionary processes that shaped our genus around 1 million years ago. The muddle in the middle is not fully resolved, but a shape is beginning to emerge. It is a story not of simple descent, but of divergence, migration, coexistence, and hybridization, a braided river of ancient peoples moving across continents long before our species began its own outward journeys. The next steps will depend on expanding analyses, digging deeper into East Asian fossil localities, and integrating ancient genomes. As new material comes to light, including the anticipated full preparation of Yunxian 3, the contours of our family tree will sharpen. Much remains to be discovered, but Yunxian has opened a door. Through it we glimpse not just the bones of the past, but the branching pathways that made us human. Please let us know your thoughts in the comments and check out our other videos to learn more.